Greetings to everyone. I am Tamayolula and I will be doing an introduction addressing the soul bridge misconception. Electrochemistry is a challenging topic for students. It is a challenging one because students must connect the visible lab action to invisible molecular movements. A major hurdle is how a galvanic cell completes its circuit. Many students believe electrons travel through the soul bridge. So this stems from taking the word bridge literally and misinterpreting textbook diagrams. This analysis explores the root causes of this error and provide targeted strategies to help educators teach the difference between electron flow in wires and ion flow in solution. Thank you.
Greetings to everyone. My name is Siphumelele Nguse and I'll be doing a dialogue under section A with my peer here, Yolula, and the topic is chemical systems. Hello, Yolula. Did you study for the electrochemical cells test for tomorrow?
I tried, but galvanic and electrolytic cells are still confusing me.
Same here at first. Which part is confusing you?
The soul bridge part. I think electrons move through the soul bridge part from one half cell to the other.
Actually, that's a misconception. Electrons do not move through the salt bridge.
Oh, really? Then what's moved through it?
Ions move through the salt bridge, not electrons.
So what is the purpose of the soul bridge then?
The salt bridge keeps the solution electrically neutral by allowing ions to move between the half cells.
Then how do electrons move?
Electrons move through the external wire from the anode to the cathode.
Oh, so the wire carries the electrons while the soul bridge carries the ions.
Yes, exactly.
I've been getting that wrong.
A lot of people confuse that part, so I understand.
Another thing that confuses me is the anode and the cathode.
So what about them?
I thought the anode is always negative and the cathode is always positive.
That's only true on galvanic cells.
Wait, seriously?
Yes, in a galvanic cell, the anode is negative because the oxidation releases electrons there and the cathode is positive.
Then what happens in the electrolytic cell?
In the electrolytic cells, the charges are opposites. The anode is positive and the cathode is negative.
Yo, that's so confusing.
It helps if you try memorizing it by always saying oxidation happens at the anode and the reduction always happens at the cathode, no matter the type of cell.
So the reactions stay the same, but the charges can change depending on the cell.
Exactly, now you get it.
Why does the charge change in the electrolytic cell?
Because electrolytic cells use an external power source to force a non-spontaneous reaction to happen.
Okay, now I understand. I kept thinking galvanic and electrolytic cell work exactly the same way.
They are similar, but there are important differences.
Thanks, Pume. You just cleared up two big misconceptions for me.
No problem, Yolula. Now let's hope these questions come out in the test tomorrow.
So now we will analyze the two misconceptions that came up in our dialogue. The first misconception is that students think that the electron flow through the soul bridge in a galvanic cell, and this is incorrect because the soul bridge contains ions, not free electrons, and the electrons flow through the wire from the anode to the cathode, and the soul bridge allows ions to flow through the half cells to keep the charge balanced, and the negative ions move towards the anode and the positive ions move towards the cathode. And why do students develop these misconceptions? First, from everyday experience, and the students know that the bridges connect things, so the students assume that they assume that the electrons cross through the soul bridge, like the cars on the road. And if the students if the misconception is not corrected, the students will struggle with the electrolytic cells and the electroplanting and also the understanding of how batteries work. The second misconception is that the students think that the anode is negative and the cathode is positive in both galvanic and electrolytic cells, which is incorrect because the electrode side changes depending on the cell type, and in a galvanic cells the anode is negative and the cathode is positive. And in the electrolytic cells, the anode is positive and the cathode is negative. So like, if this misconception continues on happening continuously, it will lead to confusions and sometimes language barriers, because of the technical terms, and the students will be memorizing instead of understanding what is really happening. And if this misconception is not corrected continuously, it will lead to misunderstanding, because students will not understand the electrolysis and the corrosion happening. Now for our reflection, through this assignment, we learned that misconceptions are random errors, and many misconceptions come from everyday life, and we also learned that misconceptions are difficult to change, but there are ways that the teachers can use in order to correct the misconceptions. The teachers can like create a dialogue in a classroom and allow students to make prediction according to their understanding, and also can create a cognitive conflict in a classroom, so that they can demonstrate by using the demonstration that contradicts the misconceptions. So that is our end of our presentation. Thank you.